Okay, so we have this paper with some extra factoring problems on it that we're going to take a look at for today. And we're going to focus just on the two things that we know how to do so far. So yesterday in class, we talked about factoring by pulling out a GCF. And then your notes video was factoring using what we call the grouping method. And that's something we use when we have 4-term polynomials. So that's what we're going to look at here. The first thing I want you guys to do is take a look at just out of the first 6 problems. I would like you to circle the problem number of anything that has a GCF. Just look at the first 6 problems. Circle the problem number if it has a greatest common factor that you could factor out. If your mask is not currently covering your nose and mouth, please pull it up. I should not see your whole face. So out of just the first 6, what did you circle? Circled 3, I agree with. 4 almost. These 2 terms are both even, but we don't have a lead coefficient that's even. 2. What would be your GCF if you circled 2? Yeah. So technically, we could pull a GCF out of 1, a GCF of 1 out of everything. But let's just look at GCFs that aren't 1. For these first few, I think that's just 3. What would be our GCF here? 2. These are both divisible by 2, so I could factor out 2. So we would take 54, is that x cubed, and divide by 2. So what is that? 20, what did we say? 27. So we would have 27x cubed. And then the second part, let me drop this down first. 27x cubed plus, what do I get when I take 2 out of 2? 1. Yeah, that 1 is important. Because remember, when I distribute back, I should get the same thing. So if I were to multiply this back and I didn't put the 1, I would get the 54x cubed, but I wouldn't get the plus 2. So that 1 is important. Okay, let's take a look at the rest of these. Just looking for GCF, just looking for common factors, something I could divide out of every term. A little more, here we go. Any other problems that have GCF? Maybe factor we could divide out of every term. $14, 11, I heard 8, I heard 9, and I heard 15. What would be your GCF for 8? So there isn't one, but I think that there should be. Okay, fair enough, but can we agree that there isn't a common factor there? Okay, sure. How about 9? What I heard 9 thrown out. Just 1, yeah. So we've got x to the 4th minus 1. There's nothing that we can pull out of there. Nothing besides 1. Nothing exciting that we can pull out of there right now. 16, yeah, we could pull something out of 16. Okay, so let's pull the GCFs out of these. For number 11, what would be our common factor there? They both have an x, so we can pull out an x. And then 3, yeah, 6 and 15 are both divisible by 3. Very good. So what would that leave me with if I factor out 3x? 2x. So many people ready to answer. This is great. Okay, yeah, 2x plus 5. Remember, you can always check this by distributing. So 3x times 2x would give me 6x squared. 3x times 5 would give me 15x. You can always check by distributing. Let's go to 14 next. What's my GCF for 14? 2x. What do I have left if I factor out 2x? X squared. And then what was that last part? Minus 16. Good. How about you guys try 15 and 16? Just pull out that GCF, and then we'll check in just a minute. What's my GCF for 15? The coefficients are both divisible by 4, and then both of these terms have x's. They also have exponents. So remember, I can pull out as many x's as the smallest exponent. So I can pull out an x cubed here. And then that would leave me with 12x minus 1. Remember, if you need to, you can think of this like the term divided by our GCF. This is really what I'm doing. We talked about this yesterday, right? I'm dividing out that GCF. So my x cubes would be gone, and negative 4 divided by 4 would be negative 1. So that's why I have that minus 1 there. What's my GCF for 16? 12. So when I factor out 12, what do I have left? X to the 4th plus x squared minus 2. Perfect. Okay, so that's all the problems that have a GCF. Your notes video from your homework was about factoring by grouping. So the next thing I want to look at are any problems on here that have 4 terms, because remember, it's 4-term problems, 4-term polynomials that we use grouping to factor. Okay, so just as I take a look at these, I would not use grouping for number 1 because it's not 4 terms. I wouldn't use it for number 2 because it's not 4 terms. Not for 3 or 4. I would use grouping for number 5 because number 5 has 4 terms. So for our grouping method, remember the idea behind it is that we take this thing that has 4 terms and we split it up into groups of 2. For the problems that you will see in Algebra 2, you won't have to do any rearranging. If you need to factor something by grouping, the order it's in will be an order that you can use to factor. So I don't have to worry about swapping anything around. If I've got 4 terms, I'm going to split it up into 2 groups. So there's the first group, and there's the second group. Okay. Then I look for the GCF for each of these groups. So for right now, I'm going to completely ignore that second group. I don't care about those guys back there at all. I just care about the GCF for x cubed plus x squared. What's our GCF there? X. Yeah, x squared, right? That's the smallest exponent here, so I can pull out an x squared. And then what would I be left with? If I factor out x squared, what's left over? x, and then what was the other part of that? Plus 1, perfect. And now I'm going to ignore that first group and just focus on the second group. I've got negative 4x minus 4. What's my GCF there? 4, right? Yeah, and then actually I'm going to pull out negative 4. Anytime my group, and this is in your video too, anytime my group starts with a negative, I'm going to probably use that negative as part of my GCF. So I'm going to factor out negative 4 as my GCF, and that would leave me with x plus 1, perfect. Here's why it's important I pulled out that negative. When I've used negative 4 as my GCF, my stuff in parentheses here matches what I got here. Anytime I'm factoring by grouping, that stuff in parentheses has to be the same. I need it to be the same because now it acts like my GCF, okay? Remember in that practice we did yesterday where sometimes our GCF was a big clunky thing? You guys had problems that looked almost exactly like this yesterday that we worked on. The reason we worked on problems like that is because it kind of set the stage for what we're doing here. Now, out of this whole thing, I have a GCF of x plus 1. And left over, when I factor that out, is x squared minus 4. Now, what I have left, these individual factors here, I don't have any GCFs within those factors. I don't have anything in 4 terms. That's as much factoring as we can do right now. What's another problem that we can factor with our grouping method? 10 and 7. So we'll do 7 first, and then we'll get to 10. So for number 7, your first step when you're factoring is always to look for a GCF. But remember, we already went through each of these problems looking for a GCF. So we would have pulled it out already. So we don't have a GCF here to start. So we're going to go ahead and split these up into their groups. And then for the first group, what's my greatest common factor? What's my GCF here? X cubed, very good. What's left over? X plus 2. Now for my second group, what's my GCF here? There isn't an exciting one, right? They don't both have an X. They're not both divisible by 2. If there isn't an exciting GCF, then we're going to pull out 1, okay? Anytime I'm factoring by grouping, I have to have a GCF for each group. If there's not an obvious GCF, then it's just going to be 1. So I'm going to pull out a positive 1 here, which would leave me still with x plus 2. Now I've got my thing in parentheses that's the same, my sort of big clunky GCF that I can pull out, x plus 2. And then I'm left with x cubed plus 1. Questions for me on number 7? You guys try number 10. Give number 10 a try. What's the very first thing I want to do with number 10? My very first step to try to factor this. Do what? Even before I start looking for GCF, split it into groups, yeah? And then what's my first GCF? X squared. This first group has a GCF of X squared. What's left over when I factor out the X squared? 3x minus 2, perfect. How about my second group? What's my GCF there? -3, yeah, my group starts with a negative, so that's a pretty good hint that my GCF is going to be negative something. In this case, -3. What does that leave me with? 3x minus 2. Remember, factoring out that negative will change the sign. If I didn't pull out a -3, then my GCF would have, if I use 3 as my GCF, my stuff in parentheses would have been -3x plus 2, and that's not the same, right? Then I would have a problem. So that's why we wanted to make sure we pulled out a -3 for our GCF there. Now what? What's my next step? What comes out now? Yeah, that stuff in parentheses is my new GCF, and it comes out. What am I left with? Perfect, x squared minus 3. Questions for me on the problems that we've looked at on this page? Okay, keep this. We're going to come back to it next week. But for right now, you can put this one away. In your notes packet, I have just a couple more problems I want you guys to try. So in your notes packet on page 31, you're flipping ahead a little bit. In your notes packet on page 31, I have 3 problems I would like you to try. For homework tonight, you have a notes video that's going to introduce our next method for factoring. Tomorrow in class, we're going to do some more practice with our GCF and our grouping to make sure we have those down pat. One of the strategies you're going to see in your notes video tonight for factoring 3-term things, factoring trinomials, is going to be basically a way that we can rewrite problems to use grouping. So we're going to do a little more practice on grouping tomorrow. And then next week, we'll focus on factoring trinomials, factoring things with 3 terms.